Hello and welcome to the Graphing Polynomials video. In this video, we're going to take a look at some of the features that we talked about in class earlier today, as well as actually now taking a step to graph. We're going to be going over 3 problems from this packet. It's going to be problems 1, 6, and 8. So you're going to see me skip around, but let's get started. So if we take a look here at problem 1, it says complete the characteristics found from each given polynomial function, then sketch a possible graph. So we're not going to be making a table, we're just going to be going based off the information that we have here. So the first thing that I see here is my x and my y intercepts. I'm going to look over here to see how can we find those intercepts. Well, if I take each of my factors and set them equal to 0 and solve, those are going to give me my intercepts. So if we do just above it, x is equal to 0, x minus 2 is equal to 0, and x plus 2 is equal to 0, and solve from there. So I can see one of these I already have done. When an x is by itself, we're going to have a root at 0. So remember when I'm talking about root, I'm talking about my x-intercepts. So we're going to have a root, or an x-intercept at 0, 0. When we use our middle one to solve, x minus 2 is equal to 0. It's going to be a positive 2, 0. And then my second one's going to end with a negative 2 and 0. And remember, for x-intercepts, our y values will always be 0. That's why they end in 0. For our y-intercepts, our x values are always 0. So you can go through the process of plugging in 0 for each of these x's and solving. However, I already know that one of my x-intercepts is 0, 0. So this is the case when my x is 0, what's my y value? Also 0. So I can see my y-intercept is going to be 0, 0. So I'm going to take a moment right now and plot those points. And I'm also going to plot in these axes just a little bit better. I didn't really photograph well. There we go. So these points, we know we have one at 0, 0. We have one at 2, 0. We have one at negative 2, 0. Okay, so we have our x and y intercepts graphed. Next, it asks us to find the degree of the polynomial. So to find the degree, you can either multiply all this out and find the largest term, or you can look at the multiplicities or exponent of the factors. I see that the x squared has a 2, but the other factors don't have anything. Well, those actually are invisible ones. So we're going to take this squared, this 1, and this 1, add those together, and we get a degree for polynomial. Now, next, it asks for the end behavior. So for that end behavior, it's asking, which way are your arrows facing? Well, since we have a degree 4 polynomial, that tells us that we're going to have an even polynomial, so both my ends should be facing the same direction. And I don't see any numbers out in front of here, so I'm going to assume that's a positive 1. So if we have a positive leading coefficient and an even degree, this is going to look something like an x squared graph, where both of my ends are facing upward. I don't know exactly where they're going to be facing upward, but I'm going to kind of put them in my graph, just so I know, hey, both my ends should be going upward. The last feature it asks, it says to describe description of the graph at each root, depict the type of curve at each root. So this is how I'm going to split it up. I'm going to put the root here. I'm going to list the multiplicity here. I'm just going to write mult. And then I'm going to put a picture of what it's going to look like here. So we have 3 roots, or x-intercepts. That first one listed is when x is equal to 0. This one has a multiplicity of 2. And when there's a multiplicity of 2, it means there's a bounce. Now, I don't know if it's exactly looks like that. I don't know if it'll be facing upward, but I do know it's going to look like a U shape around my x-axis. My next root we have is at x is equal to a positive 2. This has a multiplicity of 1. This is going to look like it's just going straight through the x-axis. Now again, I don't know if it's in this specific direction, but I do know it's going to go straight through. My last root, or x-intercept, is when x is equal to negative 2. Also has a multiplicity of 1, and it's also going to go straight through. So now that I have all of my features, I've graphed as much as I can. Now I'm going to connect all of my information. So I know that here and here, it should go straight through the graph, and at 0, it's going to have to bounce off the graph at some point. So let's try and connect these. So starting with my arrow here, I'm going to go straight through this point. I got to turn around at some point to get back here, and I know I'm supposed to bounce off. I come back around, and I got to come back here, go straight through my graph, and connect to my arrow. It's not the prettiest looking arrow, but I can see, okay, we have a graph. I see that we bounced or have something that looks kind of like a quadratic around this x-intercept. Both of these go straight through, and both my arrows are facing upward. So I start with one arrow, and I just kind of work my way through. It has all the behavior we need. Now you might ask, Ms. Twain, how did you know how far to go here? Why is one deeper than the other? Honestly, we don't know the actual placement. We haven't scaled our y-axis. We haven't plugged in anything to see. That's why the instructions say, then sketch a possible graph. This is what it could possibly look like. Maybe they're even. Maybe this one's all the way down here. We really don't know. So if your graph is different than your neighbor's, that's okay. I'm really more looking for the behavior around your x and y intercepts, as well as which way are your ends facing. But this is one problem. Let's try 2 more. Let's see, next we're going to be looking at problem number 6. So if we scroll all the way down, I took out a few pages, so my problem 6 is going to be right here. First, see here, we're looking for our x and y intercepts, but I look at this and I go, ooh, that's not a factor. I need this to be factored completely. So for some of these problems, you may have to take an extra step. So here, we're looking for 2 numbers that multiply to a positive 25 and add to a negative 10. And that's going to get us a negative 5 and a negative 5, and this is being multiplied by that x plus 1. Now, x minus 5 times x minus 5, there's another way I can write that. I'm going to write that as x minus 5 squared. So we have a multiplicity being multiplied to that x plus 1. So when we go through, find our x and y intercepts, I'm going to set these factors equal to 0 and solve. So for that x minus 5, if I set that equal to 0, we're going to end up with a positive 5 of 5, 0 as one of our x-intercepts. And the other one of x plus 1, if I set that equal to 0 and solve, we're going to get a negative 1. So we'll have negative 1, 0 as our other x-intercept. For the y-intercept, it's not going to be as quick as the other one, just because, there's no example here of when x is 0. So what I'm going to do is I'm going to take this information right here, plug in 0, and solve. So if I try 0 plus 5 squared times 0, this should be minus. Here we go, 0 minus 5 squared times 0 plus 1. This is going to be a negative 5 squared times a positive 1. Do not forget that squared. But we end up with 25, not negative 25, 25 times 1, or 25. And again, this is for our y-intercept. So we're going to write this as 0, 25. Next, for our degree, we're going to add up our multiplicities. So we have a 2 right here, and we also have that invisible 1. So that 2 plus a 1, that's going to give us 3. And for our end behavior, we have an odd degree. So our ends are going to be facing in opposite directions. And I don't see a number out here, so I'm going to assume that's a positive 1. So a positive leading coefficient and an odd degree, it's going to look something like a cubic function. So we can see that our ends look like this, where the left end is facing down and the right end is facing up. So I'm going to go through, I'm going to mark in what we have. So let's see, get my axes redrawn in there. So let's see, we have 1, 2, 3, 4, 5. We've got a root there. We've got one at -1. And then for the y-intercept, again, we haven't scaled the y-axis. I'm just kind of draw the best I can, and then I'll kind of put in the 25 later. But this is what we have so far. Oh, and we know that our right side's going to go up, left side's going to go down. So we've got that connected. And let's do that last step of describing the roots, talking about their multiplicities and what their curve looks like. So again, we'll write the root, we'll write the multiplicity, and we'll kind of draw a quick picture so we know what it's supposed to look like. So our first root is that x is equal to 5. This one has a multiplicity of 2 because of that squared. So that means we're going to be bouncing off the x-axis in some way. Our second and last root is when x is equal to negative 1. It's a multiplicity of 1, so it's going to be going straight through the graph. So when we try and connect all of our points, I always start with my left arrow. I'm going to start down here. I know I have to go up through this x-intercept. I have to come around at some point, we'll call that 25, to come back around to hit this x-intercept, but we have to bounce off again. And end facing upward. So it doesn't exactly match up with this arrow. That's okay, it doesn't have to. We can see my ends are going in the correct direction. I have the correct behavior, so we're bouncing here, and we're going straight through here for our x-intercepts. And lastly, we can now say, hey, we're going to call that 25. We will do a little bit more precise graphing on Monday, but for right now, I'm okay with just this. So this is an example when you may have some factoring, but let's take a look at some other type of multiplicities. So we're going to move down to problem number 8. This one's worded a little bit differently, but this one's factored all the way. First it asks, what is the degree of the polynomial? So I look up here, oh, we got so much stuff going on. This factor, it looks like it doesn't have a multiplicity, but it really has a multiplicity of 1. So I'm going to add up all of my multiplicities together. We got a 2 plus a 1 plus a 3. So it's going to leave us with a multiplicity, or pardon me, a degree of 6, and 6 is an even number. So this function is even. It asks if the function is positive or negative, so I'm going to look out front. I don't see any numbers there, so I'm just going to assume it's positive, like a positive 1. Then it asks for the end behavior. So for the end behavior here, we have an even degree and a positive leading coefficient. So it's going to look something like an x squared, where both of the ends are facing upward. And then last it asks us to find, or one of the last things it asks us to do, is find those x and y intercepts. So let's find our x-intercepts first. If we set each of these factors equal to 0, we're going to have x is equal to 0, x minus 3 is equal to 0, and x plus 4 is equal to 0. You can show me that work if you want, but you don't have to. But I'll be able to see that for my x-intercepts, we're going to have 0, 0. I see that one right away. Our second factor, our x minus 3 is equal to 0. If we solve that, we get x is 3, the y value will be 0. And then for our last factor, x plus 4 is equal to 0, we're going to subtract 4 on both sides and get negative 4, 0. So in this case, we're going to have 3 x-intercepts. And for our y-intercept, again, this is like problem number 1. We already have 0, 0. So that's going to be our y-intercept. I'm going to go through right now, graph everything that we have so far, and then we'll do that last piece where we describe what's happening at the roots. So let's see, I know we have 0, 0. We have 1, 2, 3, 0, and negative 4, 0. Okay, so we have that so far. Lastly, again, we're going to look at the root, the multiplicity, and we'll kind of draw a picture for it as well. So our first root is when x is equal to 0. That has a multiplicity of 2, which means we're going to be bouncing off our x-axis. Our next root is when x is equal to 3. That has a multiplicity of 1. So we're going to go straight through our x-axis. And lastly, the new one, we're going to have a root when x is equal to -4. This is a multiplicity of 3. This is the highest multiplicity we'll be dealing with. But it looks like a cubic function. It kind of wiggle, wobble, squiggle. There's a lot, teachers use a lot of different words for this. I have always heard of it as a chair. And it goes through our x-axis, but not straight through like a multiplicity of 1. It kind of has a little bit of a seat. So let's make sure we check that out. So when we take a look at our graph, I just realized I forgot to put in my arrows, so I will do that. See, they're both supposed to be, oops, it's not a great looking arrow. There we go. It looks something like this. I know that right here, it's supposed to look like this, but it may not look exactly like this. It may be backwards. So I'm going to start here and say, hey, I know this has to connect to here. So I'm going to start here and do like a little chair thing. So first arrow is going up. And then from here, in the middle, I'm going to bring it down. So the way that I like to draw these is to do half a parabola up, half a parabola down. Or if I'm going the other way, half a parabola up, half a parabola down. That way I can see that it kind of levels off for a moment. And if I do it all at once, I don't often hit the x-axis correctly. So feel free to take a moment, practice doing that. But I can see I've done it here and here, making sure it doesn't have to connect to this arrow, but it's going up. When I get back to my graph, I go, okay, we're down here. It has to turn around to get to my next intercept, to here, but I see it bounces off. So it's got to go down, then it's going to come back around. It's going to go through this x-intercept and head upward. So is it the prettiest graph? No, but that's okay. I can still see that I'm going straight through here, I'm bouncing off here, and there's like a little bit of a weird wiggle here, and both my ends are facing upward. If you're worried that I'm not going to be able to tell as I'm reading your Go Formatives or your test that I know this is a multiplicity of 3, if you just want to be like, that's a multiplicity of 3, like if you just want to physically point that out, you can very much do that. Anyway, we're going to be continuing to practice these problems tomorrow in class. Let me know if you have any questions, and I look forward to seeing you tomorrow.